Hello and good afternoon, CTS265 Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this afternoon's video tutorial is going to be our continuation into Chapter 6, where we're taking a look at Internet connectivity, and specifically in this activity, we're going to be walking through some basic IPv6 Internet connectivity scenarios here. We're also going to be taking a look at an IPv6 ACL configuration, and we're going to compare and contrast how we do IPv4 ACLs with how we would be setting up IPv6 ACLs. So as you can see, our topology is pretty straightforward. Step one, we simply need to assign router 1 with the provider assigned, right? So in other words, this is not provider independent, it is provider aggregatable. In other words, the provider is giving us, they own the IP address space, and so therefore they are assigning the address to us. And then you can see right here, it's going to be a 2001 DB8 101010 or 1010::10/64. So let's go ahead and jump onto router 1 here, and let's get into global config, and let's say do show IP interface brief. And actually, how about a do show IPv6 interface brief? Even better. So we can see that the Ethernet 00 is configured, Ethernet 01 is configured, and here is 00 and 01. These are our inside interfaces. And now we're taking a look at Ethernet 02, that outside provider-facing interface. So let's go ahead and get into interface Ethernet 02, which has no configuration on it currently. So we're simply going to say IPv6 address 2001:DB8:10:10:10/64. Now, if I rerun that do show IPv6 interface brief, what we notice here about Ethernet 02 is that we've been assigned an IPv6 address, right? We manually assign the IPv6 address, but we assign the global Unicast address, right? So this is a global Unicast address. You can see the IPv6 link local address has automatically been assigned to us through the EUI64 process. And so we end up with this very long string of random characters. We know it's EUI64 because we can see right here in just about the middle, we've got the FF:FE. And so remember, what happens is the MAC address is taken, and actually I only really need to go that far, and then the 7th bit, so there's 4 bits in that hexadecimal character, so the 5th, 6th, the 7th bit in the 2nd hex character, this gets flipped. If it's a 0, we flip it to a 1. If it's a 1, we flip it to a 0. And then we insert FF:/FE into the middle, and then we precede it with the 48 bits on the front and the FE80::, or the FE80, and then there would be 2 groups of all zeros. 1, 2, 3, 4, 5. I'm sorry, 3 groups of all zeros would be in the middle. So 48 bits total that we put on the front end with that FE80, right? Okay, so that's a little brief overview on EUI64. So let's make it easy on ourselves here. We're going to go ahead and say IPv6 address FE80::1 link local. So we're going to set our link local address to FE80::1. Makes it a little easier to track. And then finally, you can see we're administratively shut down. So we're going to say no shut, and we're going to bring this link up. And there we go. So now the do show IPv6 interface brief, Ethernet 2 or 02 is up, and we have our global Unicast address assigned. All right, now it's also asking us to create a default route, an IPv6 default route. So I would simply say IPv6 route ::/0. Remember, the :/0 is equivalent to saying IP route quad zeros. All I need here is ::/0, and the next hop IP is going to be the address over here, which, actually, now that I think about it, we'll roll the dice here. 2001 DB8, it's probably 1. :10:10:10:1, but let's check. Do ping 2001:DB8:10:10:10 1. And did I typo that somewhere? 2001 DB8 1010::1. I think I'm missing something here. Do show IPv6 interface brief. Do ping. Aha! All right. So do you see the mistake? And you probably saw this far earlier, or much earlier than I did. Let's get back to the IPv6 address assignment here, and let's make sure, and let's get into interface Ethernet 02. Hopefully that'll come back. And now, remember, we still need to say, I need to pull this back and put the incorrect address in there, which was the 2011, or else it would stay on that interface. There we go. So now when we try to ping out to 2001 DB8:10:10::1, all right, now we've got connectivity out there. Everything looks good. So we're going to test from the TFTP server. Right, so if I come over here to the TFTP server, this is 2001 DB8:04::10. Excuse me. So let's jump onto the server and let's test out to the internet. 2001 DB8:10, or actually, I'm sorry, :20:20::1. And we're testing IPv6 connectivity. We've got it. So now finally, let's try from the PC. Can we connect out to the internet? So we'll say ping 2001 DB8:20:20:1. And again, that is the address that we're pinging here. On the PC, I obviously had another typo there. And there we go. All right, so we've got connectivity from the PC and from the server, as well as router 1 to the internet. So, and again, that's kind of the basic setup for our IPv6 connectivity. Again, a very, very simple solution here in order to ease us into the discovery activity. So now we're going to talk about configuring IPv6 ACLs. And so remember, let's compare and contrast for a second. So the first major difference with IPv6 ACLs is that there are no numbered IPv6. You cannot do a numbered IPv6 ACL. Like with IPv4, I could say access list 1 or IP access list 10, or IP access list and then name it. I'd have to do access list 1 or access list 101 to do an extended ACL. With IPv6, there is no numbering of ACLs. They are all named. And the other significant difference is that all IPv6 ACLs are extended ACLs. There are no standard IPv6 ACLs. So again, with IPv6, it is always extended and it is always a named ACL. Now, remember at the end of the IPv4 ACL, where we always had that deny any at the end, sort of our catch-all at the very, very end of an access list. Well, with IPv6, there are actually 3 rules that you'll find at the end, and these are the 3 implicit rules. 2 are permit, and 1 is a deny. So you have a permit ICMP, any neighbor discovery, neighbor advertisement, and then neighbor discovery, neighbor solicitation. So ND-NA and ND-NS. And that's to allow neighbor solicitations and advertisements to go back and forth between the nodes. And then finally, we have a deny IPv6 any at the very end. So it's true to say that the last line does do the same thing that you have in IPv4, but it's the 2 lines before that which are also implicit that we don't find with IPv4. And again, it's because we're running IPv6 and we need to allow that neighbor discovery, neighbor advertisement, and neighbor discovery, neighbor solicitation traffic to make its way through. If we didn't do that and we had a deny IPv6 any at the end, that's it. We would be dead in the water from an IPv6 perspective. Okay, so now what we're going to do is we're going to go ahead and it looks like in step 3, we're going to configure and apply some ACLs. So again, remember, let's jump over here onto router 1. Remember that we need to make sure that we give it a name, right? So IPv6 access list, and you can see here Word. It has to be a word. Now, could I make the word 101? Well, let's try that. Invalid access list name. So if you were thinking to yourself, oh, wait a second, I like using numbers, and so I'll just put a number in and it'll take it as the word. And you can see here, that's not going to work. So let's go ahead and pull this back, and we're going to simply call this secure. So IPv6 access list secure. Now we can put remarks in here just like we could with our IPv4, and we're going to say no ping to TFTP server. TFTP server. And then we'll say deny ICMP any. So we're denying ICMP traffic from any originator to the host, to the host 2001 DB8:0:4:10, and you can see here we get to pick what it is we're going to deny. So we're going to deny the echo request. So an echo reply may come in, but there will be no, I'm sorry, echo reply. There may be an echo request that tries to come in, but we are blocking that, so there will be no echo reply. Sorry about that. Tripping over my own explanation. So now let's go back for another remark, and we're simply going to say no telnet to TFTP server. Right? Obviously, we don't want anybody accessing the TFTP server either. So we're going to deny what? Telnet uses TCP from anywhere to the host 2001 DB8:0:4:10 equal to what service? Telnet. There we go. Now let's put another ACL in here. So we're going to say remark, and we're going to say allow TFTP traffic to TFTP server. All right, so now we're going to permit. So remember, TFTP uses UDP, so we're going to say permit UDP from anywhere to the host 2001 DB8:0:10 :4:10 and equal to what service? Equal to TFTP, right? Okay, and then what we're going to do is we're going to deny UDP. So we've just permitted it through to the TFTP server, but now we need to deny UDP from anybody to anybody equal to TFTP, right? And so again, what we're doing here is we're basically saying that as this IPv6 ACL is evaluated, the first rule that it hits according to TFTP says if it's coming in from anywhere to only the TFTP server host, then we are going to allow that traffic. And that's the only traffic that we give a check mark to and say, yep, it's coming through. And then we've got this deny UDP any equal to TFTP. So we're denying any UDP traffic coming from anybody going to anybody that is TFTP, so UDP port number 69, right? And that's how it differentiates TFTP from the other services. And you can see trivial file transfer protocol is right there, port number 69. So this is the rule that's going to make sure that we're not allowing TFTP through to anybody else. And we need to have that rule in there, or else we would be allowing it. All right. So now that we've denied some things, we've allowed some others, at this point we're good. We're simply going to say allow all. So this final rule here is going to be permit IPv6 any. Now remember, at the end of this ACL, we have those three specific lines that come into play. And they would be, I'll type them in here, but again, they're implicitly there, but I'm typing them so you can see what they look like. So permit ICMP any, neighbor discovery, neighbor advertisement, and then neighbor discovery, neighbor solicitation, right? So those two, in addition to the deny IPv6 any, those last three right there are implicit. So you don't have to type them. I'm putting them here so that you can see what they look like. But again, you don't have to type those in. Those are there auto-magically for you. So now we've got this IPv6 ACL. Let's apply this IPv6 ACL to interface Ethernet 02, which is that ISP facing interface, or the outside facing interface. Now this is also different. Remember, if I said IP, what would I typically put here if I was doing an IPv4 access list applying it to the interface? Exactly, I would say IP access group, and then I would either put the number of my ACL, standard or extended, and the name of my ACL. But remember, this is IPv6. So if I say IPv6 question mark, you can see, boy, do we have a lot of things that we can choose from. But we are interested in traffic filter. So IPv6 traffic filter, and then the name of the access list, which we just said was secure. Now, just like IPv4, I need to say, am I looking at this in the inbound directions? In other words, coming from the internet, or is this in the outbound direction going to the internet? So, whoops, sorry. So we're going to say this is inbound, right? Because this is coming in from the internet. So let's test these out. If I click on the internet host here, you can see we can actually access that internet host. I'm going to ping to 2001 db8:0:4:10. So I'm going to ping. So before I ping, let's pull up show IPv6, access list, and secure. So there is my IPv6 access list. Again, remember that these were typed in, that I actually typed those in. So deny ICMP from anybody to 2001 db8, et cetera, et cetera, et cetera. So we should see what? Success or failure here. Whoops, click in there. We should see failure, right? Because we're denying ICMP. In fact, I could say repeat 1,000. And it doesn't look like, oh, it's going awfully slow. So again, you can see here that this is not going to get through. And so that is why we see that letter A, telling us that we are not able to get through. And not only does it tell, and I guess let me expand on that. So not only does it tell you that you're failing, right? We're not seeing the period, constantly like we do with IPv4, but the A specifically stands for administrative, or in other words, we're trying to go through with our ICMP request packets, but we are administratively being denied. And so by administratively, it's trying to indicate to us that something has administratively been done. In other words, someone has done something to specifically deny this type of traffic. All right. Control-Shift-6. Okay, good. Bailed me out there. All right, so now let's go ahead and try telnet to, and actually, can I pull back the ping command? And we're going to go ahead and say telnet 2001 db8:0:4:10. Should this be allowed? No, remember we denied telnet. Destination unreachable or gateway down, right? And that is what we're going to see. So finally, we're going to try to do TFTP. So we're going to say copy TFTP : / 2001 db8:0:4:10. And actually, I apologize, :5. We're going to the TFTP server : 10 / startup config, and we're going to call it, oops, null 0, or just null, sorry, null. So can I do this? Is this going to work? Going to 5 / 10. So it says accessing TFTP. If I come back and we take a look at R1, what did we say about TFTP? We said permit to 4 / 10 equal to TFTP, but everybody else was denied TFTP access. So let's come back to the internet, and you can see it's just kind of hanging here, and eventually, I hope, that this is going to simply time out and crash. Well, we'll do Control-Shift-6. Excuse me. But you can clearly see that this is not working, and in fact, that not only is it not working, it appears to have locked up my window, and I guess we may be stuck here for a second. Let me give it a few more seconds here before I simply reload the node to get us back on track. All right, so it definitely did not like having to wait around for that. So let's go ahead and manage devices, and we're simply going to reload the internet router, or I should say the internet host. So inet, and we simply want to reload. Okay, so we'll get to watch this happen. So we'll get the internet server back. All right, there we go. So the internet server is back. So now let's go ahead and try to ping 2001 DB8:0:5:10. So we're going to be trying to ping that server on the inside. And so ICMP request a 5:10, which is the PC work. So all of the previous tests were to the TFTP server. Now we're checking connectivity to the PC. So I can ping the PC from the outside. Can I telnet to the PC? Let's get telnet spelled properly here. Absolutely. Take a look there. I'm on the PC. Can I get into... Oh, no password. So it's not going to let me get into privilege exec mode there. But again, you can see that we're connected. So I'll type exit, and there you go. So I was able to ping, and I was also able to telnet. But now let's see if I can do TFTP. So copy TFTP : / 2001 DB8:0:4:10 startup config to null. And since we're going to the TFTP server, this should work. And there we go. And TFTP was running on the TFTP server. Okay, so the last thing we're going to do is let's go ahead, and we've already taken a look at the ACL, but let's jump back over here and see what we see in terms of matches. So before, not much information, but now take a look. One of the other differences is typically the matches show up at the end and the sequence numbers at the beginning. With the IPv6 ACLs, you can see we've got the sequence number that started at 20, it looks like by default, and then it goes up 20, 40, 60, 70, 90, 100, 110, 120. So interesting incrementing there by the IPv6 ACLs, but we can see the matches that we had, right? And we ran lots of ping requests through, and we can see that those were also being denied. All right. Well, this is going to wrap up Discovery Activity 21. Again, sort of our first foray into setting up IPv6 external connectivity with a quote-unquote ISP. And this is going to become important as we go into our 3-week sessions on, or over 3 weeks, the sessions on BGP. And specifically when we start to talk about doing dual stack, or when we start to talk about doing IPv6 over IPv4, and how we're going to deal with setting up our IPv6 addressing. All right, thank you so much for watching, and I will see you guys on Monday night.